So just like we've been dealing with fractions in the past where you don't want to have a radical in the denominator, we also don't want to have an imaginary number in the denominator because it also is a radical. So in order for us to fix this, what we're going to do is we're going to multiply the numerator and denominator by the complex conjugate, what we just practiced that a minute ago, of the denominator. So the complex conjugate of the denominator. So let's start off with a relatively easy one, just a not as complex of a complex number, pun partially intended. We got 3 plus 10i over 5i. Now, the denominator is just the imaginary part. If it helps you think about it as 0 plus 5i, so that way you can kind of think about, like, well, take the opposite of the imaginary. We need to multiply the numerator and denominator by negative 5i. Now to put parentheses around the numerator and the denominator. We don't really need the 0. If you want to put it around it, more power to you. But now we're going to go through and just multiply it out. We got 3 times negative 5i, which gives us negative 15i. And then we have 10i times negative 5i, which gives us negative 50i squared. In our denominator, I'm going to ignore the 0 because 0 times negative 5i is just 0. So we have 5i times negative 5i, which gives us negative 25i squared. Now, cleaning this up a little bit, knowing what we know from the previous part about multiplying, negative 50i squared, that's negative 50 times negative 1, so that's really plus 50. And then negative 25i squared, that's negative 25 times negative 1, that really means it's a positive 25. So if we rewrite this, putting it in standard form, we've got a 50 minus 15i up top. Down below, we just get 25. That's not too bad. Now, we can also reduce that fraction a little bit. I would encourage you to separate it out into two separate pieces. We're going to have 50 over 25 minus 15i over 25. So that way we can reduce each part of this. Now, 50 over 25, that reduces really nicely to be just 2. 15 over 25, we can reduce those. We can divide both of those by 5, giving us 3 over 5. And you can put the I up top or out back. It doesn't make a difference to me. But this is the simplified version of this. We rationalized the denominator. There we go. That's the phrase I was looking for. So 2 minus 3/5 I, or 3i over 5 works as well. Let's try one with a little bit more in the denominator. So we have 8, goodness gracious, 2 plus 8i over 4 minus 2i. We're going to multiply the numerator and denominator by 4 plus 2i, the complex conjugate of the denominator. Now this is going to require a little bit more work because obviously there's more terms here. But we're going to just distribute. So we got 2 times 4, just focusing on the numerator. 2 times 4 is 8. 2 times 2i is 4i. You got 8i times 4, which is 32i. We have 8i times 2i, which gives us 16i squared. In our denominator, we got 4 times 4, that's 16. 4 times 2i gives us positive 8i. Negative 2i times 4 gives us negative 8i. And then negative 2i times positive 2i gives us negative 4i squared. Cleaning this up a little bit, in our numerator we got 8, that's all by itself so far. Actually let me switch colors. 8 all by itself so far, plus 4i plus 32i. These two we can combine, giving us plus 36i. And then that 16i squared, plus 16i squared, remember that's plus 16 times negative 1, in other words, minus 16. In our denominator, we've got 16. Then we have plus 8i minus 8i. They cancel out. That's the beauty of using the complex conjugate. Those I terms should cancel out. Now we also have minus 4i squared. Well, that's minus 4 times negative 1, so plus 4. Cleaning this up more, in the numerator, we've got 8 and minus 16 giving us negative 8 plus 36i over our denominator of 20. Reducing the fraction, or breaking it up, we got negative 8 over 20. We'll fix that or reduce that a little bit, plus 36i over 20. Negative 8 over 20 we can reduce, divide both of those by 4, we get negative 2 over 5. And then 36 over 20, we can divide both of those by 4 as well. We get 9 over 5i. So we have negative 2/5 plus 9/5i.